In the meantime, whilst we were away, I asked Claude to write a Mondrian schema that then sits over the database that we have created. So for those of you who weren't paying attention or want to catch up, in the first section, we created a pharma demo Postgres database just on my laptop here. We have loaded 250,000 facts into it, and we have also then loaded up the dimensions that go with it. So whilst I am aware that a chunk of people will hopefully understand what this means, let me click another button. Aha, there we go. I get to use the top-down camera, so hopefully the battery doesn't go flat whilst I do this, but I do want to try and explain a little bit of dimensional modeling to anybody who is new to how this stuff works, because I'm going to say words that don't make a lot of sense to various people, and I would like to be able to demonstrate in real time how this works. So let me find the right end of the pen. The other thing I also have to apologize for is my handwriting is awful. So hopefully I'm going to draw some large boxes and you will get an understanding of some of this. So I've just mentioned fact tables and I have mentioned dimensions that go with this. And so if I draw a box in the middle of here, and this is going to be fact pharma. And if I move this down a bit so you can see it better, there we go. So we've got fact pharma in the middle of here, and then I'm going to then draw a line up here, and we're going to have another box. And this one is going to be called dim date. And then somewhere down here, I'm going to draw another box, and I'm going to call this one dim geography. Let's do it shorthand. And then I'm not going to do it because I'm sort of belaboring the point, but I could then add more and more and more lines on. And so they all hang around the middle of this, what we know as a fact table. Now, a fact table, as you can probably imagine from the name, contains a number of facts. And those facts are measurable aspects to your data. Now, because of the way that we're going to do it, in our case, they're all numbers. But they could be other things, depending on what platform and what processes you are using to be able to deploy and analyze this. But the fact table is generally the core of all of these schemas. And from a data modeling perspective, these are star schemas, generally because you can draw a bit of a star. If you were doing web application development or something like that, you would look more at a snowflake schema. But also with the way that the databases work these days, you might also just end up with one very wide table without the other bits around the outside. You would still model it in this sort of way, but the table itself may just be one very wide table, because the way that some analytics databases work, that works better for them. Getting too into the weeds, but you get the idea. Dimensions that sit around the outside are things that you want to be able to report against. So in this case, the date dimension will have things like years, months, quarters. It might also contain financial reporting periods. So if you have a business year that's offset from the calendar year, you would probably put that in your date dimension. If you have different geographies, you have a geography dimension down here. We looked at some of that data in the previous period, but by doing that...
Can't see the drawings.
I'm talking and no one can see it. There we go. I forgot. I knew I would do this at some point, and I forgot to push the transition button. Anyway, you can see here, I have created the the fact pharma table, the date dimension table, and the geography. So in doing that, this is the start of our star schema, and as I was explaining, which no one could see, this allows for us to then be able to report differently, but the database under the hood, the actual tables, may be laid out a little bit differently to this, but this is basically how you would model it. So stuff like geography allows you to then link to a pharmaceutical record, but without having to pollute that table with like endless amounts of ways that you want to be able to report it. Because of course, as we saw in the earlier build out, when we were talking with geographies, you're talking both like, you know, zip codes, states, you know, geographic locations. It may be countries, it may be continents. There's a lot of stuff in there. Your date dimension, probably, if you were to model this properly, would end up with, you know, just 50 columns, possibly more, if you were actually going to like do a full date dimension. A lot of people don't do it these days, but like if you really wanted your date dimension to be expansive, 20 to 50 columns is normal. So you don't want them to be in your fact table. So this is the type of thing that we're trying to build out using the modeling that we've just done, and now a Mondrian schema that we're then going to use for analysis. Now, a Mondrian schema itself is basically either a YAML file or an XML file that explains to our piece of software or anything else that runs basically the Mondrian OLAP server how your data is modeled in the database. There's lots of different platforms that do very similar things. They all require some sort of like understanding how this is built. And the reason that we do this is because in reality, what we want to be able to build out for our users is a standardized format that allows for repeatable analytics over the same table sets time after time. It also gives us other benefits like caching and that type of stuff. But basically what we're looking for is building a model that allows for an entire organization to be able to report the same way on the same data. So by creating these fact tables and these models, you're not then just giving, you know, the users direct access to the database. You're constraining them by the model that sits over the top. So that if you want to be able to calculate profit, for example, you've got one way of being able to create profit across the entire organization, if that makes sense, so that you haven't then got your accountants, you know, creating one profit metric versus your sales team who are trying to create it against different calculation, and that ends up skewing your numbers. And so this is why these semantic models exist over the top of your databases, and you don't just let your sales team loose on your database itself. So if I go back to sharing the screen, what I did during the break was I asked Claude to go and have a look at the database that we created. So earlier on in the show, we created a database. And if I scroll back up, make this a bit bigger as well. If I scroll back up somewhere up here, yeah, there we go. We created a database, the pharma demo database, and that's what we used inside of the ETL. And then I said, okay, I've loaded up various data tables. Can we create a Mondrian schema that matches these tables to run in Seku? We will get into Seku in a second. But basically, Claude then went and had a look in the Postgres database, understood how the data was created. So you can see like one row here in terms of date key, date dimension stuff. And then he's gone and created a pharma schema that sits over the top of it. It wasn't quite perfect. It didn't work the first time, so I said I logged in but can't see it, so he went to check the logs. He built a couple more tweaks into it, and then I said, you know, it seems to be all right. And so that's basically where we've landed at this point in time. So I will now say, can you print some of a schema on this screen for people to read? There we go. So as this thing rolls through, you can see that it's printing out this XML file. And so this XML file is the pharma schema. It's got a cube in it called pharma RX. And we will get into some of these naming conventions in a little bit. But, you know, we've got a cube, got default measure. We've got a table inside of a dimension. We've got this date dimension. We've got product. We've got prescriber. And we've got some measures and a calculated member down the bottom just for fun and games. And so this is sort of where we're at from a a Mondrian perspective. And this is the model that sits over the database. So this describes how the dimensions connect to the fact table and so on and so on. And I know that I'm saying a bunch of words that are not necessarily the most obvious, but some of this will become clear in a minute when we switch to another screen. Now, we've done some quite cool stuff as well. So there is the ability for Seku to flag PII data and start to potentially scrub some of that. We have new aggregators. We haven't used any of them here, but there's various new bits that have come into Seku as well that you can then leverage to be able to show things on the screen.